Hi, I'm Robert Dwyer, and today for my part of the project, I'm going to talk about question 3 on exam 1, the tank problem. So the first thing we're going to do is we're given this tank and we have to solve for two variables. So the way we're going to solve it is by checking each tank individually, making sure the amount entering the tank, the input, is equal to the amount leaving the tank, the output. So we have to make sure this number right here and this number add together equal these two numbers leaving. So for tank 1 plus 5 is 6, which is, excuse me, and then 4 plus 2 is 6, so that's good. Tank 2 plus 6 is 8, is equal to 5 plus 3, which is the two parts leaving, which is great. Tank 3 plus 5 is 8, 6 plus 2 is 8, so that's great. So now we solve the system. That's a quick little check to make sure. Now, once we have our tank solved, we can now solve for A1, A2, and A3. Now, A1 is just going to be tank's one system, which is individual parts of each variable coming from separate tanks or outside sources. So the 1 times 6 is just the outside source, and then subtracting the parts leaving the tank, which is the 4 and the 2 of A1, B1, which is the tank itself. And then we're adding 5 because there's 5 coming in from tank 2. Now for A2, there is 2A1 over V1, which is the 2 from tank 1 giving to tank 2, 8 leaving overall from tank 2, which is the 5 plus 3 right there, and then 6 entering from tank 3 into tank 2, which is right here. A3 is 3 entering from tank 2, which is right here, 8 leaving of tank 3, which is the 6 and the 2 up here, and then 5 times 8, which is from coming from the outside twice. And now since we solved for A1, A2, and A3, we are just going to make it into a simple AB matrix. This is the B matrix right here. It is 3 by 1 column right matrix. So 3 rows, 1 column matrix. And then this 3 by 3 matrix is A. So the way we're going to solve this or fill this in is for the B matrix is our simple constants of the tanks. So 6 comes from up here in the A1, which is the 6 coming from the outside source. 0 for tank 2 because it's a closed system. There's nothing an outside source entering tank 2. And then the 40 comes from right here, also on the outside source, the 5 times 8, which is right there, and right here as well. Now for the A matrix, we're just going to take these numbers that are in terms of A1 over V1, A2 over V2, and the A3 over V3. So now for each row symbolizes each tank itself. So the top row is tank 1, second row is tank 2, and the third row is tank 3 as itself. And each column symbolizes what A1 or A2 or A3 is doing. So for example, row 1, column 1 is there's 6 and leaving from tank 1, and there's 5 entering from tank 2 in tank's 1 system, and 0 entering from tank 3. And then for tank 2, which is row 2, there's 2 being received from tank 2 from tank 1. There's 6 leaving tank 2 system, which is right here, and 6 entering, sorry, this is not 6. This is a little typo. This is 8 leaving tank 2 system and 6 entering tank 3 system right here, coming in from tank 3 system. So this should still be negative, and this is positive right here. And this is a 6, and this is an 8. Now for tank 3 system, we have 0 coming from tank 1, 3 coming in from tank 2, and then 8 leaving of tank 3 itself. So now that we have this simple matrix, we're just going to plug this in mathematic code, and these are your answers right here. But I'll just show you the code real quick and explain that. So this is the code. This is just our simple AB matrix just put in Mathematica. And as you can see, you can double check. I did fix the error in the code itself, which is a good check. So use this more for studying. B, simple. So we're going to do, and then V1, V2, and V3 are the initial amount in each tank, which is a good check because it's right here. Tank 1, tank 2, and 0, 3, 4, 7. And then what we're going to do is write y of 0 as a matrix, and then just linear solve of A and negative B. And then after that, we're just going to get our matrix, so which is the end point of each tank. So after the whole process is done, this is what it's going to be left with. And these are your eigenvalues, which is what the question asks for itself. So as you can see, it gives you negative 3.09, negative 1.56, negative 0.48. And so that's your answers, and that's how you would solve for question 3 in exam 1. I'm Robert Dwyer, and thank you.